This is Pre-Calculus B, Unit 3, Lesson 5. We're working with the law of cosines. Lessons 4 and 5 are really all about solving non-right triangles, and we use the general rules, the law of sines and the law of cosines, to solve them. So let me reiterate what those laws are. The law of sines says that the ratio of the sine of an angle to its opposite side is constant for any given triangle. Sine A over A equals cosine B over B. Not cosine. Getting off track. Sine B over B, big B, little b, sine big C over little c is constant. And by the way, you can flip that. You can say A over sine A, B over sine B, C over sine C, because reciprocals are still true when you have a proportion. That's the law of sines. The law of cosines is very much related to the Pythagorean theorem, and it can be thought of as a more general case of the Pythagorean theorem. A squared equals b squared plus c squared minus 2bc cosine A. And I want you to note a couple of patterns going on here. Bookends. It starts and ends with A, right? So it starts with a side and ends with the opposite angle. The other two sides, B and C, are squared and added and multiplied by each other, and by -2. Okay, so just remember it that way and it works pretty well. A side squared is equal to the other two side squareds minus 2 times the product of the other two sides times the cosine of the angle between them. If you remember it that way instead of remembering letters per se, it'll help greatly. Okay, so let's use these to solve a problem. In this case, I'm going to solve, we remember, if you recall, we started with the law of sines by solving the angle side and the angle side angle cases. And we use the law of sines for that. Okay, for the other two cases, side angle side and side side, the law of cosines is necessary, but we're actually going to use both to solve the triangles completely. So let's do it. Okay, so here we go. We've got a triangle, non-right triangle, and we're going to set up a side angle side scenario, A, B, C. Okay. A, B, C, A, B, C. Singing A, B, C, easy as 1, 2, 3. Talking about do, re, mi. A, B, C, 1, 2, 3. I don't know if you guys remember that. That's an old Jackson 5 song from the 70s. All right, little a, little b, little c. Okay. All right, so let's say we are told the following. Let's say we are told that little a is 8 inches and little c is 10 inches. And we're told that angle B is 47 degrees. Okay? We want to solve the triangle. That means we're going to find angle A, angle C, and side B. Those are the three remaining facts. Now, remember our rule or law for figuring out if the law of sines applies. Our rule is we need a side angle pair. Do we have a pair of B's? No, I'm missing little b. Do we have a pair of A's? No, I'm missing big A. Do I have a pair of C's? No, I'm missing big C. So no pairs, so I must use something other than the law of sines, and the law of cosines comes to mind. Now, if you remember it as a side squared equals the other two sides squared and added minus 2 times the product of the other two sides times the cosine of the angle between them, this is not a problem. But you may note that I actually need to start with B and not A, right? Again, if you remember relative position, B squared equals C squared, 10 squared, plus 8 squared, minus 2 times 10 times 8, times cosine of the angle between them, 47. Okay? So take the square root and b is approximately the square root of both sides. Too long. Trying to draw a straight line, sketch a straight line. All right, so let's grab our calculator. And the cool thing about today's calculators, when I took this class, I would have had to have entered this all piecemeal. We had, oh, here's an ancient one. Reverse polar notation, check that out. We had calculators that worked on reverse polar notation, especially the expensive HP calculators. All right, square root, 10 squared, but now we can enter it just the way we do write it. 8 squared minus 2 times 10 times 8 times cosine of 47. Again, you want to make sure that we are in the correct mode. If we're dealing with degrees, we need to be in degrees. So degrees is where I'm set. Okay, so we are fine there. And the missing side is 7.4. I'm going to go to the hundredths place, 7.41. 7.41. Okay? And I'm going to do something else here. I'm going to do something in Desmos. I'm going to say b equals. And what that does now is that allows me to type b and bring up that exact value without having to retype all the decimal digits later on. So use that feature if you have a graphing calculator like a TI-84 or some of the TI calculators, even the Casio and all of those. They will allow you to assign values to variables. On the TI-84, it's the store button, STO, down by the bottom left corner of the calculator keypad. All right, and then use alpha b. Okay, so little b, 7.41. All right, so we haven't finished solving the triangle, so let's find the angles. Now I do have a side angle pair, and this is how we end up using both. We end up doing both. So I have a pair of b's, okay? And so the law of sines now applies. So I'm going to say sine 47 over b, and I'm just going to put b because I'm going to remember that on my calculator rather than 7.41, equals, and I can pick a side. I'm going to say sine a over little a, okay? And remember the variable b has already been discovered, so I'm going to use it, leave it there. But I'm going to solve the proportion by multiplying the diagonal that a is not on and dividing by b, okay? So sine A equals 8 times the sine of 47 divided by B. And then inverse sine or arc sine of A. So A equals arc sine, usually written with a little -1. It can be A sine, ASIN, or ARC-SIN as well, depending on where you're typing it. Sine 47 over b. Okay? And let's go ahead and calculate it here. Now in Desmos, if you're typing, it takes arcsine, ARC-SIN, ARC-SIN. You can bring up the sign little -1 by choosing the keyboard that brings a keyboard pop-up and then choosing arcsine here, right? But I prefer to type ARC-SIN because it's faster. Okay, arc sine, 8 sine 47, all divided by b. Now, b is an actual number, 7.41, but if I use b now, it uses all those digits, and I don't have to worry about round-off error. Okay, 52.17. Okay, and arc sine gives me an angle, 52.17 degrees. Okay, and the other thing I'm going to do here, so I don't have to type that again, is I'm going to say capital A equals 52.17. Okay, and now to find angle C, it's simply a matter of using the fact that the triangle angles should add up to 180. So C is 180. Take away B, which is 47. Take away A, which is 52.17. Okay, so let's enter that here. So we're going to do 180, take away 47, take away capital A is 80.83. 80.83 degrees. And we have solved the triangle. Okay, so hopefully you picked up a few tips, a few pointers. I'm going to do one more video where we solve the side case.